Okay, so today we're going to talk about Newton's laws of motion and force. So yesterday you should have read a little bit about Newton's first law and just about force in general. So we're just going to give you a little overview of the three laws today. Sir Isaac Newton lived from December 25th, 1642 to March 20th, 1727. He was the first person to unravel the mysteries of motion. He developed three basic laws that describe different aspects of motion. I know the most famous part of his story is him sitting under a tree, the apple falls, and he discovers gravity. And there are some other things that he did as well. All right, so what is force? Force is a push or pull. It is gives energy to an object. It can set the object in motion, it can stop an object's motion, and it can change the speed or direction of an object's motion. Motion is the result of forces. So if no outside forces act on an object, there is no motion. Newton's first law of motion is the law of inertia. It says that an object in motion or at rest will remain in that state unless acted upon by an unbalanced force. And so we've already talked about this concept of inertia when we talked about momentum. But the law of inertia states that whatever motion that the object is in will remain same direction, same speed, same everything, unless there is some kind of outside force or unbalanced force. So inertia, by definition, is a tendency to resist a change in motion. An object moving in a straight path must have an outside force act on it in order to change its speed or direction. So in class, I use the example of why is it when I throw a baseball, does it not go on and on and on and on and on forever? Why does it eventually fall? And those are the outside forces that are working on it, air resistance and gravity and things of that nature, which we'll discuss in this unit as well. A force must act on an object to change its motion. That is the essence or the summary of the law of inertia. There has to be some outside force or some unbalanced force that changes the object's motion. All right, so the second law, this is the math law. The force of an object is equal to the mass times the acceleration. Okay, now this is not velocity because remember, momentum is mass times velocity. Force is mass times acceleration. So our units are going to be a little bit different. It's the mathematical relationship between force, mass, and acceleration. F equals ma. And then here's your triangle. So force equals mass times acceleration. Mass is equal to force divided by acceleration. Acceleration is going to be equal to force divided by mass. So we'll do some calculations, I think tomorrow or Friday or Monday maybe on these. All right, so units of force. Forces are measured in newtons, okay? Force equals mass times acceleration. The mass is measured in kilograms. The acceleration is measured in velocity over time, which gives you meters per second squared, as we know. And 1 Newton is equal to 1 kilogram times meters per second squared. So you could express your answer in kilograms times meters per second squared or newtons, okay? And obviously the newton comes from Isaac Newton. All right, what is the third law of motion? All right, so for every action, there is an opposite and equal reaction, okay? For every force, there is a reaction force, okay? So this is the concept of if I hit something, it bounces back, or if I step off a boat, I go in one direction, the boat goes in the other direction. These are all examples of Newton's third law of motion. So this explains why rockets work, because obviously there's the combustion here, and the force that comes out pushes against the ground, and the ground pushes against the force, and that's what launches the rocket off the ground. Okay, so we have balanced forces. If the forces are equal and in opposite directions, they are balanced. So if I'm pushing to the right, you're pushing to the left, and we're both pushing with 4 newtons of force, then the forces are balanced and there's no change in motion. Okay, if I'm leaning against the wall is leaning against me, then there's no change in the direction. If I push too hard on the wall, then the wall will move. Okay. Objects resting on a table also are balanced forces. Otherwise, the box would fall through the table or the table would push the box into the air. So these are balanced forces. They're acting equally and oppositely upon each other. Now, unbalanced forces. Unbalanced forces are forces that are not equal or not in opposite directions. Okay. Unbalanced forces result in motion. Okay, unbalanced forces change the motion or direction of an object. Okay, for instance, the skater on the ground is exerting a force on the skater, but the skater is exerting a force to move across the ice. Okay, this is an example of unbalanced forces. Obviously, the stronger person is going to win this tug of war. Opposite direction forces subtract. Motion is in the direction of the greater force. So what that means is if I'm pushing from this side with 20 newtons and someone else is pushing from this side with 5 newtons, the net force is going to be 20 minus 5, which is 15 newtons, and we will move to this direction because this is in the direction of the greater force. Motion that goes in the same direction are combined. So if we're both pushing with in this direction to the right, one with 18 newtons and one with 7 newtons, and we would add those together, and these would be combined forces. So opposite forces subtract, combined forces add. All right, so this is where we're going to stop for today, and then we'll pick up on Tuesday with gravity, friction, and force diagrams. So make sure you've got all the way through these 3 laws, and then we're going to read about the 3 laws. We're going to do some calculations with law number 2, and then we'll be ready to talk about gravity, friction, and force diagrams.